reaction is basically the reaction where aldehyde or compound containing alpha hydrogen atom is converted to a compound that is called aldol. So for this, the first condition is the requirement of diluted base. So first the requirement is, so diluted base means the concentration of the base is lower, diluted base. So base like example, for example NaOH. So strong and diluted is different. So NaOH is diluted, then it will be like 50% NaOH or 40% NaOH in concentration, or sodium carbonate, that is Na2CO3 can be used, or further BaOH whole 2, or it is called barium hydroxide, also used. Then this is the first criteria of aldol condensation, and the second criteria is the use of compound having having alpha hydrogen atom, that is alpha hydrogen atom containing compound. So now if any aldehyde or ketone is whether containing alpha hydrogen or not, how this is determined? Let me give an example like CH3 C double bonded O CH3, and another example is HC double bonded O and H. So here the functional group is C double bonded O, and here also the C double bonded O is the functional group. Now the adjacent atom, that is this carbon atom, is alpha carbon, and here it is also the alpha carbon atom. But here you can see that no adjacent carbon atom is present. So here alpha carbon atom is absent. So alpha hydrogen is not present in this compound, and in this compound alpha carbon attached hydrogens are alpha hydrogens. So here at this side 3 hydrogens are alpha hydrogen, and at this side another 3 hydrogens. So number of alpha hydrogen in total is 3 plus 3, 6 alpha hydrogens overall in this compound. So it matches the criteria of the aldol condensation, but this compound does not match the criteria of aldol condensation. So if two substrates are there in the reaction, at least one substrate or compound must contain the alpha hydrogen atom. And the third criteria is, what is the general product formation? So like any aldehyde or ketone with alpha hydrogen atom, and it will respond to the reaction and it will form a compound that is named as aldol. So by this compound's name, the reaction is called aldol condensation. Okay, now I will give you the definite example. Let me erase this thing. So if I give an example to you that a compound like acetaldehyde CH3, so hydrogen in expansion mode, it is written as like this, and it is bonded with C double bonded O and H, so overall aldehyde functional group. Now this carbon atom is the functional group, so the adjacent atom, this atom, carbon atom, contains 3 alpha hydrogen atoms. So like this, if we use a base like sodium hydroxide, then the OH minus part of the base will abstract the hydrogen atom from this compound, from hydrogen. So OH minus will abstract it, and the negative ion will form a enolate. What is enolate then? So negative ion here is formed, and it will conjugate with the adjacent carbonyl group. So it will conjugate like this, and the other hydrogen remain as it is. So we can use a reversible sign and the enolate is formed like carbon double bonded O minus and it is attached with a hydrogen atom. So the rest of hydrogen atom is here like this. Okay. So if we use a aldehyde 2 molecule, then another aldehyde will remain as it is, C double bonded O H, and here a CH3 group is attached. Now if this negative charged get back, so this one will attach to the carbonyl carbon atom because the carbonyl carbon atom is delta positive in nature because it is a polar bond and it is attached with a oxygen atom which draws its electron density towards itself. So now if we combine these two things, we will get that C double bonded O, and here if we put it in a different direction, then hydrogen will be here and the another thing CH2 will be in this side. So it is attached to the C double bonded O and it will abstract a H plus from the solvent and it become OH. Now CH3 will be here in this direction. Now this OH attached compound is just the with respect to this carbonyl carbon, it is alpha and this is beta carbon. So it can be named as beta hydroxy aldehyde, and this compound is actually named as aldol, and as per this compound's name, the reaction has been also named as aldol condensation reaction. This is aldol. Okay, I think now it is very clear to you. Okay, now if we write this compound again, then we can write this like C double bonded O, here H, then C H, and here in the below H will be attached C OH, and this carbon will be attached to a methyl group, that is CH3. Now this hydrogen, let me change the color, this hydrogen and this OH simultaneously break down and get eliminated. So here a double bond formation can occur. Generally here in a heat condition and in an acidic medium, it is found to be happen. So here the double bond formation occur and H C double bonded O, CH double bonded C and CH3. Okay, now here one hydrogen should present. Okay, one hydrogen should present here also, so valency will be filled. Now here the OH and H is removed, so ultimately dehydration reaction happens here. So here one hydrogen present. Now this compound, because of this alpha position and beta position, it is named as alpha beta unsaturated carbonyl compound. Okay, so in this reaction, aldol condensation reaction, the aldehyde that is used is only aldehyde, no other thing. So if one aldehyde and another type of aldehyde is used, then it is called that mixed aldol condensation. So let me give an example, and I think it came in NEET exam. So now if we use another example, like let me draw the structure. So here one benzaldehyde is used, CH double bonded O, and with this an acetophenone is used, like benzene ring, and with this benzene ring on ketomethyl group COCH3 group is attached. Okay, so now the trick is here, like this CH3 group will get enolated and it will be attached with this CH double bonded, that is carbonyl or aldehyde functional group, and the reagent used is dilute NaOH, that is the base. Okay, now if the compound is formed, that is called aldol, as we know. So benzene and the CHO group become OH. So the trick is this CHO group become OH, and the compound, this compound containing alpha hydrogen, this is alpha hydrogens, will converted to enolate form, and like this is the CH2 and it is attached to the carbonyl group CO, and the rest thing is attached with the benzene ring. Okay, so this compound is here aldol of different type, aldol of different type, and here you can see that this compound does not contain any alpha hydrogen, no alpha hydrogen, but this compound contains alpha hydrogen. So the criteria is at least one compound should contain alpha hydrogen. As this aldehyde group and the another keto group having different nature, so this can be called as mixed type of aldol condensation. Okay, so now further, if it is treated with the acidic condition and it is heated, then overall water elimination occurs and it will generate a alpha beta unsaturated compound. So like here double bond will be formed and it is attached to the carbonyl, and further it is attached to a benzene ring. So this compound that is formed is actually on 3 diphenyl prop 2 in on. So this is the compound name, and with respect to this carbonyl group, this is alpha position and this is beta position. So it is another type of alpha beta unsaturated carbonyl compound. So it is very important. Okay, now if in a specific condition, if a varied thing is given, like after erasing this I can show you that. Okay, so if in an example it is given that carbon is attached to 2 different CH3 or methyl groups, and further this carbon is attached to a OH group. Okay, now the adjacent carbon, that is CH, is attached to a hydrogen atom, and further it is attached to COCH3. So this is keto functional group, this is keto functional group. Okay, now if this compound is treated with iodine I2 and heat is provided, then what will happen? So here water elimination occurs, H2O get eliminated, and here the elimination is called dehydration. So elimination is occurring, so here in this compound box elimination can be applied, and here H and OH in overall, and overall H2O gets eliminated, and the compound that is formed is carbon bonded to CH double bond, then CH3 will remain as it is, and CH further connected with COCH3, and thus this compound is formed, it is also, you can see, alpha beta unsaturated compound. Alpha beta unsaturated compound is formed here. Okay, now I will give you example of intramolecular aldol condensation. Intramolecular aldol condensation. Okay, let me underline this. So in intermolecular condensation reaction, you can see this in a single molecule it will happen, and the compound will terminated in a cyclic compound. Okay, so let me give an example like CH3, then it is bonded to C double bonded O, then further it is bonded to CH2. I am writing in a curved arrow, curved manner, because it will be then easy to understand. So here CHO. Now you can see that here if a NaOH base, dilute NaOH base, 50% NaOH base or any other base is used and heat is used, then you can see this hydrogen will be eliminated. Here a negative charge will formed and it will form a enolate, and after that this carbonatron will be attached to this aldehyde group, and a cyclic compound with the number of carbon atom like here 1, 2, 3, 4, 5, 6, with 6 carbon atom, a cyclic hexagon will form. And here in this compound I can write like this. Here the CHO group become OH as it was in the earlier examples, and further if this H and OH gets eliminated, it will form the next compound like here double bonded carbon is formed and here double bonded O is formed. So this is alpha beta unsaturated compound and the previous one is the aldol one. So because it is happening in a single molecule, so it is called intramolecular condensation reaction. So like this, it is all about aldol condensation reaction. I think it is more than enough for you, and you can understand this by